Hi, this is Phil Worrall. I'm the project engineer for NIST's 3D hydrography program for the nation. And this presentation is on AI, machine learning, large language modules, GPT, all things to support GIS. I gave this presentation earlier this week at the NIST mid-year conference, and I decided that I only had 15 minutes to give the presentation, that I wanted to record it. And this is the director's cut version. It has a little bonus extra content, and I'm going a little slower pace than at the conference. So, a few terms we get into: artificial intelligence and machine learning. Artificial intelligence refers to the computer software that mimics our human cognitive ability. And machine learning is simply a subfield of AI that focus on training algorithms with data sets to produce models capable of complex tasks. The importance of AI and machine learning in GIS today is very significant and growing at an exponential rate. We have an explosion of geospatial data, both in volume and complexity. And there's really too much data to be processed using traditional methods. So AI and machine learning is really a solution for these processing challenges. And we're seeing that in many places. And the term that is being used is geo AI. Where we are in that evolution is we're honestly still in very early days. And just like man evolved based on the size of his brain, so does geo AI, or AI in general, evolve with the size of the computing power to process information. So let's look at a couple case studies for geo AI that we see today. We're going to look at digital photogrammetry, we're going to look at some land cover mapping, and we're going to look at ChatGPT. Digital photogrammetry includes the things we know about and think about as standard photogrammetric processes: arrow triangulation, autocorrelation of images to create surface models, image analysis, LiDAR point classification. All kinds of things are using AI today, and it's entrenched in our existing processes and software. But there still is really a substantial manual involvement required today to obtain reliable, high-quality results. So this evolution has to continue to become more effective and more automated. We're seeing some really interesting examples of that happening and available. Microsoft Planetary Computer recently released Pearl, which is an AI machine learning tool to do land cover mapping. And you can freely go on the Microsoft Planetary Computer site, and using the Pearl engine, you can pick from 1 to 3 different land cover classification models. And in this case, I took an area of interest and classified 8 features from NAPE imagery that was available on Planetary Computer. Compare that raster result on the right to, on the left, the more traditional photogrammetric compiled planimetric map, consisting of basically only 3 features. Take that to the next level. We have our NIST business partner Ecopia with some very good examples of using high-resolution ortho imagery to create over 20 different 2D vector features and multiple 3D vector features like buildings, bridges, tree cover. And these are very accurate, high precision now vector models that can be used right out of the box to begin doing geospatial analysis against. So we're really revolutionizing the planimetric compilation or capturing process. And everybody should really be starting to take advantage of this in your communities and across your states where you can. Let's look at the next generation, which is large language modules and GPT. A GPT, fancy name for a Generative Pre-trained Transformer. It's a type of large language module that has been trained to predict the next word in a sentence, or based on the question, the context, it can take the context and understand and predict what the answer is. Large language modules are AI models that are built on neural network to take advantage of these neural network-based models. And that technology is basically behind how an LLM and a GPT works. So from natural language processing, we have the ability to mimic how the human brain processes language. And through that power in the computer, we can start doing some very interesting things. Some of the things we can do are not just with text, they're also with code, with both the creation and the execution of programmatic code, the processing or the creation of images, audio input and output, video, we talk geospatial, LiDAR point cloud data, etc. Any type of media can now be included in one of these large language models that has multimodal capability. And so we're starting to see some very interesting capabilities there. If we want to look at the most popular APIs for large language modules and LLMs, we can see ChatGPT 3.5 and 4, developed by OpenAI, but there's also Google, Meta, IBM, NVIDIA. There's a whole slew of developers that are building large language modules. Likewise, the multimodal large language models platforms. For visualization, the DALL-E from OpenAI, very popular these days, and also their data analyst, and I'll show you that in a bit. As you go on, you get into the world of custom GPTs, and the custom GPT that I've created to support the 3D hydrography program here at NSGIC, I'll show you that as well later on. So let's look at some case studies, and specifically of GeoAI in action. So here I'm opening up OpenAI's Data Analyst GPT, and this is a general data analyst. You can give it a spreadsheet, you can give it a comma delimited file, you can ask it just a question about some data that's out there. In this case, I have dragged and dropped a GeoTIFF image of a digital elevation model, and I didn't tell it what it was, but you can see from the narrative here that it looks at the name, it analyzes the data format, and it understands what I have just given it to be a digital elevation model. That in itself is pretty impressive just to begin with. What I then asked it to do was to please display a color hillshade of that DEM. So what it did is it looked at the available open source software libraries it had available in it. It found one, and it wrote the Python code to generate a digital elevation, a hillshade from the digital elevation model. It made an error in the processing initially, so it came back and it self-corrected, and then completed the task, and then displayed the hillshade. I was pretty impressed with those results, with basically no custom training of this model at all for doing geospatial kind of processing. So the next thing I asked it to do was to create a geomorphic index, a GMI raster from that same DEM. And the geomorphic index is a tool used with elevation-derived hydrography to display the geomorphology features so that you can use it for both defining hydro features, but also quality control of the hydro features you have on your map. So I asked it to do that, and it generated the GMI actually quite easily on the first try. Now, there's a lot of parameters and a lot of settings that by default it made, And I would not guarantee at this point that this GMI raster is suitable for my application. But the fact that it can do it, and the fact that I could give it further instructions to constrain it, I have a lot of confidence that I could create the product I need suitable for the task I'm trying to perform. And I've done this with no GIS software on my desktop. So we have, if nothing else, we have some very pretty pictures we can show off of the results from that DEM. Looking at custom GPTs, since November 2023, OpenAI has released this capability for people to subscribe, developers to create their own GPT. And there are literally thousands of them in their library, in their public marketplace. I used keyword searches for things related to mapping and GIS, and I literally found within a minute or two almost 100 different public GPTs that have been created related to geospatial. And these are all available within that developer's market space. One example that I thought was very fascinating was this development project by University of South Carolina and Pennsylvania State University, where they used the API for GPT-4 to develop several case study examples of doing geoprocessing from what they called self-generating to self-organizing, self-verifying, self-executing, and self-growing. And this is a real couple fascinating examples in the links there on GitHub if you want to look at this further. But I'll just show you really quickly. What they used was something called prompt engineering, where they define the task, they define the data, they tell the GPT where those sources are, and then they give a bunch of rules or guidelines for performing the processing. They have not written one line of code. The GPT will do that, but they basically constrained it and told it how to do it. The end result then is a map. Prompt engineering is really the magic sauce behind all of this, and it can be as simple or as extensive as you want and as you need. But obviously, the more prompts and the more constraints, the more exact your output is going to be for your requirements. The other two examples they had, the one of interest on the left is not using static data that they provided, but it's using a REST service as input with dynamic data, so that this could be interfaced through the API into a website, and the map that gets produced when the user calls it up is generated on the fly and based on current data available through that REST service. So you start getting into some very interesting capabilities using this type of technology, especially with live or dynamic data. So here's the custom GPT I put together for 3D hydrography. It's called NISGIC's 3D HP FTN GPT Advisor. That's a bunch of alphabet soup, but we know kind of what that means. It's the 3D hydrography program for the nation. It is a GPT, and it is an advisor. It is going to give us advice. It currently is not designed to produce maps or data, but it definitely has that capability in the future. So this is the designer or developer's view of it, of the interface from OpenAI. On the left, I have my developer pane, and on the right, I have what's called a preview pane, so we can see the results of what we're doing. So on the left, I basically have a configuration and a creation panel. And what I input into the configuration panel is basically the name of my GPT, a description of it, and then in the paragraphs of instructions I put in there, this tells the GPT what I'm doing and how to do it. So I've told it that it is proficient in areas like state planning, data development, specifications, quality control, and applications of 3HP data. So that is the starting point for it. Now I need to give it basically the knowledge on which it's going to do those things. And that is simply done by, in the knowledge section, uploading the documents, the authoritative information, in this case from USGS, and also from content that we have created within NISJIC on our hub, and also from our forums and presentations at the conference, have all been uploaded into this knowledge base. And so this is what the GPT is going to understand and use to answer the questions as we go forward. I've also told it in this setting that it can learn from responses, questions and responses. So it should get smarter as more people use it and ask it questions. As an example, then, once I have that data in there, I can then go into the creation pane and start improving it. And I can improve it by asking it questions or telling it additional information, or about telling it what to do, what not to do. In this case, what I have done is I've identified that USGS has published some additional reference information that supersedes their printed documents. And they have that on their website. So I captured those web pages and I put them in a PDF document, and I uploaded them as this reference document, reference guide. And then here in the GPT, I'm telling it that anytime it's answering a question from those authoritative documents, to be sure and check this reference document for any updates or amendments. And it basically is responding, got it, I'm going to do that. So let's see that in action. I happen to know one of the amendments in this from this specification is related to ice masses. Ice masses are not a typical North American thing, but they are an Alaska thing. And ice masses are an issue because of the mapping that's currently going on in Alaska for elevation-derived hydrography. So from the original specification, we can see a fairly lengthy answer about how to manage ice masses in the development of elevation-derived hydrography. But I also happen to know that in the amended reference document, USGS has opted not to collect ice masses. So that's the before answer on how to do it. And here's the after answer. Once I've uploaded and trained it with that document, you can see that it tells you we don't do that anymore. You know, they're not collected. And then I asked it also to cite its sources. And this is the other nice thing about it. If you're ever wondering where it got that answer, you simply ask and it will tell you. And you can see it's the rule reference merge document that I provided from the website. So pretty impressive in a first simple attempt to train the dragon. So bottom line is there's a lot of potential in GIS with using these tools for AI machine learning, large language modules, multimodal language models, and GPTs. I encourage all of you to be proactive and to learn and explore and adopt these in your domains. And whether your domain is the enterprise GIS guy on the right or the little drone to map app on the left, you absolutely have the opportunity there to take advantage of these tools and technologies, and I encourage you to do so. Where we are is we're still in early days, as we saw in the evolution chart, but we are moving towards the right, evolving at a faster and faster pace. What's fascinating is the evolution is not just geospatial, it's everything. In fact, the example on the right is an automation model for the mining industry and how they can take advantage of AI and machine learning. And it pretty much mimics where we are with respect to geospatial today. the same tools can be used for solving many different problems. So I encourage you, go home, be sure you have open access to these emerging tools. Many IT departments, out of an initial level of concern, have been blocking access to things like ChatGPT. Definitely want to be sure you have access to them, and then be proactive in adopting the technology and taking advantage of it in your daily geospatial processing workflows. Closing remarks, a little bit of fun. Let's do a few limericks and see what we get. I asked it, ChatGPT, to write a limerick about 3D hydrography. I gave it a little prompting on the right because I said I told it the GIS director was from Nantucket. So it started with that. The one on the left was more free form and a little bit classier, but you get the general idea that you can also have a little bit of fun with these tools and their ability to create natural language, based on the information you've provided them. Last but not least, do not worry. Okay, AI is not going to replace us yet. And here's a prime example. A couple of weeks ago, I had the opportunity to meet with Megan Compton and her GIO's office staff, reviewing some project specifications. And these experts know all the different areas of geospatial across the state, but they like to have fun. While we were sitting there, we were also monitoring an orthoimagery flight that was happening over our heads as we were working. And Megan noticed that the plane was coming very close to where we were. So she suggested a break, and we go out and look for the plane. And by golly, we saw it. So Megan's next suggestion was, why don't we photobomb it? And we did. AI won't be doing that anytime soon. Last but not least, I need your help. I have this model, this GPT model. I now am in the testing and improving mode. We're still in a sandbox mode, but I hope to, in the very near future, move it into beta testing and more wider access. At this point, if you happen to subscribe to OpenAI's developer's license, you can find this GPT and you can access it. All you would need to do would search for 3D HP. I guarantee it's the only one out there called 3D HP. If you don't have it, that's fine. What you can do is you can contact me and I will happily do a Zoom meeting, or you can send me your questions in an email and I will ask your questions of the GPT and send you back the responses and let you help me train this dragon. So